con los terroristas.
Well, ladies and gentlemen, I'm here to show you how to get an x and y-intercept. Here we have our original equation. To get the y-intercept, you plug 0 in for x, and with this equation, it gives you the point 0, 0 as your y-intercept. To get the x-intercept, you plug 0 in for y, and then with this, you can factor out an x, and then do the quadratic equation on what is left. This will give you the points as 0, 6.8, and 2.2 as your answers for your x-intercepts.
The second part to graphing a function is finding the derivatives. To find the first derivative, you would take your exponent and put it out here, multiply it by the coefficient, and then subtract 1 from the exponent. As you can see, the first derivative of this equation is 3x squared minus 18x plus 15. This is important to find the maxes and mins of the equation. Then you go to the second derivative, and that would be doing the same thing. You would multiply 2 by 3 and get 6x minus 18. And this is used to find concavity. This is going to be the best calculus video ever! The next step to graphing your function of x, you have to find your maxes and your mids from your first derivative. So, to find your maxes and mids from your first derivative, you take your first derivative and you set it equal to 0. After you set it equal to 0, you solve your quadratic formula. Your x's on your quadratic formula are equal to 1 and 5. What you do next is you take negative infinity to 1 and 1 to 5 and 5 to infinity. What you do is you take a number below 1, which is 0, you plug it into your original equation, and you get a positive number. So that would be a positive. Then you take a number between 1 and 5, and you plug it into the original equation, and you'll get a negative number. So you go down. Then you take a number higher than 5, so you take 6, and you get a positive number, so you get positive. So then you write the numbers 1 and 5, and you'll take 1 infinity to 1 is going up, and 1 to 5 is going down, and 5 to infinity is also going up. So your max will be 1, your min would be 5. The last step you do is you have to find concavity. To find concavity, you take the second derivative of the function of x, which was explained in the last video. You set the second derivative equal to 0, and for x, you get the number 3. You do the same thing as your maxes and mins. You take negative infinity to 3, and you take 3 to infinity. When you take a number less than 3, so 2, and you plug it in to the second derivative, you'll get a negative number, so that'll be concave down. For 3 to infinity, you take a number above 3, so 4, you plug it into the second derivative, and you get a positive number, so concave up. Concave down and concave up tell you when your graph is shifting up and down. Then you have to find your point of inflection, so you take 3, and you plug it into the original function of x, and for your x you'll have 3, and for your y you'll have negative 9. So at 3, negative 9 is where your graph shifts from down, concave down, to concave up. Yeah, go calculate!
Now you're probably thinking, why is he in a swimming pool? That's a good question. Anyway, I'm going to show you the last and final part of graphing, the actual graphing portion. Now, Seth, Jimmy, and Sean have they've showed you how to get the points. And I've written all the points down that you need. To get the y's for all the x's that we've gotten, you have to plug back into the original equation. And so, as you can see, here are all the points, and here's the graph form. It's what Ms. Kerr calls a disco man graph. And the POI is at 3, -9. The point of inflection, as Jimmy mentioned earlier, is where the graph actually changes its direction. So, on the past videos, you've been able to see this down here. Hopefully